Thank you very much indeed for the opportunity to just place a quick plea on behalf of using low energy air filters. Now, this is a very much underrated component in most air conditioning systems and always tends to be overlooked, but it's surprising if you're looking for energy efficiency savings. It's a very short payback time to optimise, and it protects not just your health personally, and when I'm talking personally, I'm talking about anybody who actually has a pair of lungs and is interested in breathing clean air, as well as saving energy, then hopefully you've got an interest in this. Just to quickly say that I'll go on from the commercial slide there, the unashamedly commercial slide, to just make the point we're the largest air filter manufacturer in the world, and we do put in a lot of effort to try and encourage people to use the correct type of filters to get best value performance. And I'm sure you're all aware, as I am, and the rest of the Western world at the moment, we're in a very poor economic situation, and so anything that can be done to get value for money performance and save energy has to be a good thing. And when you have 30 to 50% of the energy in a building being consumed by the HVAC system, and quite a large proportion of that goes into the fan motor, and of that quite a large proportion is consumed by the filter, it's worth considering. And when we're talking in monetary terms, we're talking typically for a panel filter about €200 a year in electrical energy, and for a very poorly selected bag filter, F7 class, about €500–600 a year in electrical energy. So it's a lot of expense that can be optimised and saved. You can just see on this particular picture here a well selected filter. I've put an object of beauty up there. It's the only picture I've got of an air filter, so you won't have to look at another one, but that one shows you it's got 12 pockets of media entrained in the airflow going through the air handling unit. And each one of those pockets, because it has so much media in, will have a very low operating pressure drop, so the filter can clean the air very easily with the smallest amount of energy being used. And because it has so much media, it will also tend to last 2 to 3 times as long as what we call a commodity filter, which may only have 6 pockets with 380mm long pockets instead of 635. And that will mean it only has 2.9 square meters of media, as opposed to this one, which has 9.2, over 3 times as much. So you have here something that costs a relatively small amount of money, but the use of energy throughout its working life will typically be 10 to 20 times greater. So that ratio tells you straight away that if you can make improvements, the payback time will be very short and very worthwhile. And when you consider it against other renewable options out there, for example, wind turbines or solar voltaics, you're talking in payback terms 15 to 50 years as an estimate. These will normally be something of the order of about 1 to 3 months. So I don't know about you, but my bank account doesn't give that sort of return at the moment. So it strikes me as a very good way to spend public money as well, and to encourage a based up, if you like, approach. In other words, look at the individual components and optimise them in a system. It's a very good way to move forward. So apart from, of course, the energy side, I'll just quickly whip through the health side. Fine combustion particulates are causing a lot of damage to people's health now. Small particles, PM2.5s they're called, will penetrate deeply into the human lung, and anything that can be done to stop them has to again be a good thing. So you want an effective air filter system in your air handling unit. I'm just staring up at this screen at the moment above me, and I can see some plumes of black, shall we say, coming out of the supply vents, which would indicate to me that maybe the filters could do with examination for effectiveness on particulate efficiency. I've just made a friend in the plant engineer of this building, I fancy, after that one. But it's very much the case that you do suffer the consequences of lack of attention to detail when you make these selections. And it is very important that the small particles are stopped to a large level of efficiency. So this is a case of what happens to them if you don't. You only have to read the latest World Health Organization reports to tell you that there's major problems in terms of the toxic particles you get from car exhausts. They will cause cancer. They're a top-level cancer agent. And the recent, I hate to draw attention to other European studies that have gone on, apart from iSERV, but regarding health of ventilation, there's been some very august reports come out just recently, and some of you may have even been involved. And they draw attention to the fact that a lot of the burden of disease in airborne pollution is in fact based in the outside air coming into the building. If you look at this diagram, you can just see here outdoor air accounts for about 2/3 of the burden of disease, and as such it makes very good sense to have good efficient air filtration on the incoming supply air to the building. There are, of course, internally based pollutants that, again, cause health problems, and for that, of course, you would normally have recirculation and filters to deal with that as well. Just to actually draw quick attention to the solutions that have been offered, you can just maybe hopefully see those 4 bars there. The first bar gives you the ambient background pollution. The second bar gives you the reduction based on optimum dilution or ventilation of the air. The third bar there gives you the effect of having a reasonably efficient filter system. It says there PM2.5 reduction by 50%, which would require a good F7 class filter as a minimum. And when I say good F7, I mean one with the correct media, microfiber glass. And that will give you your 50% reduction, and that again will ensure that there has been a good reduction in the health damaging particulate. The last one there actually goes into source control, which is actually well, pretty much sort of making sure we don't have any power stations on, or we drive our cars in the garage and leave them there and come to work on bicycles, and we turn off our boilers or our HVAC systems as much as possible, again to reduce power requirements. It's something that is to be encouraged but isn't going to happen in the near future. So in terms of protecting our health, filtration delivers that. The standards that you need to be aware of are EN 779 and EN 13779. They're the ones that advise on filtration efficiencies. I've just got this little case study here, which is a real-life case study. Unfortunately, it's not fully prepared, but it's one that was done at a British Museum site where they were very, shall we say, lacking in trust about the delivery of energy savings, and this is something we constantly come across in my company, and I can't honestly blame anyone for that, because there are a lot of people out there saying, you know, we can deliver you energy savings, and quite often the savings to be had are not significant or not always to be realised. But on this one, we did actually set up with a test air handling unit, and we monitored the pressure drop, the volume flow rate, the energy consumption via the variable speed drive was monitored, and we actually changed the filters from some middle-of-the-range filters. They weren't the cheapest on the market, and we replaced them with our optimised low-energy air filters. And the reduction in pressure drop is written up there somewhere, and blowed if I can read it now. It's about 85 pascals, I think, was the final pressure drop, and I think the initial was 215 or something like that. But if you do the calculation, and what we actually did was we used the variable speed drive to maintain a constant volume flow rate. It worked out that the energy saving over the year, based on reducing the hertz from about 40 something, I think we reduced them by 3 or 4 hertz, and the energy saving over the year came out to around about 100 euros per aperture. And in this building there were just under 60 apertures, full-size filter apertures, so you can multiply the 60 by the 100 euros if you like, 6,000 euros for one building. And this is sort of, well monitored benefit, as opposed to using an energy equation on a piece of paper, which you can say will give you a saving but not actually seeing it in real life. So we're doing a lot of this now, along with air quality monitoring and making sure that you get real value delivery in terms of using air filters that actually work to the required level and have a very low operating pressure drop. And some of our filter systems will last up to 2 years now, instead of maybe 6 months for some of the commodity filters, which means it saves a lot of engineers' time as well. They don't have to go rushing up every 3, 4, 5 months to change the filters. They can possibly last up to 2 years. So using life cycle costing as a model to calculate the overall benefits of running a filter system is highly advantageous. I haven't really got time today, I'm probably over time already, but there are a lot of other elements, soft benefits to go into that I can't really cover, but I'd be very happy to talk about to anybody who's got any questions after the session. That just about does it. Thank you very much for your attention, and being the last here, I'm always very grateful for people maintaining attention.